Prove that the area of the triangle formed by the lines y equals to m1 times x. Then we have the other line y equals to m2 times x, and the third line y equals to c. That is going to be equals to c squared over 4 multiplied to square root of 33 plus square root of 11, where m1 and m2 are going to be roots of the given quadratic equation. Okay, let us begin. So first, let's try to understand the problem. So here we have three lines. Now these three lines are going to intersect each other such that they form a triangle. Let's try to look at it graphically. So here we have three lines, L1, L2, and L3. Now let's say L1 is represented by the line y equals to m1 times x. Then we have the line L2. L2 is going to represent the line y equals to m2 times x. And then we have L3. L3 is going to represent the line y equals to c. Now as can be seen in the figure, the line L1 and L2 intersects at the point A. Let's say, and we have L3 and L2. Let's say it intersects at the point B, and the line L1 and L3, it's going to intersect at the point C. Now clearly ABC is forming a triangle. We need to show that the area of the triangle is given by c squared over 4 times square root of 33 plus square root of 11. Okay, now in order to find out the area of the triangle, our first task will be to determine the coordinates of point A, B, and C. Now how do we find out the coordinates A, B, and C? Now in order to find out the coordinates of point A, all we need to do is solve the line L1 and the line L2, because wherever these two lines L1 and L2 are intersecting, which is actually point A in our case, that is going to give us the coordinates of point A. Now solving L1 and L2, that's an extremely easy task. So all we have to do is take y equals to m1x and substitute back in the equation for L2. So we get m1 times x is going to be equals to m2 times x, which means that x comes out to be equals to, we have m1 minus m2, that's going to be equals to 0. So solving for x, we get x equals to 0. Now we can substitute x equals to 0 either in the equation for line L1 or line L2. We're going to get the corresponding y values. So this is going to give us y equals to 0. So that means the coordinates of point A, that's going to be 0, 0. Next, we'll try to find out the coordinates of point B. So for this, we need to solve the equation for line L2 and L3. So that is going to be equals to c over m2, c. So we have obtained the coordinates of point C. So that's going to be c over m2, the y coordinate, that's going to be c. Similarly, we can find out the coordinates of the remaining point, or we can say coordinates of the third vertex, that is c, and that's going to be c over m1, c. Coordinates of point C, that's going to be c over m1, c. Okay, so now we have the coordinates of the vertices of the triangle ABC. So let's find out the area of the triangle ABC. Now we know the area of a triangle when the three coordinates value are given, then we have half multiplied to, so we need the coordinates of point A. So in the first row of the determinant, we're going to consider 0, 0 with the third number being 1, which is going to be placed in the first row, third column. Then for the second row, we're going to consider the coordinates of point B. We have c over m2, then the y coordinate, that's c, followed by 1. And then when the third row, we're going to consider the coordinates of point C. So we have c over m1, then c and 1. So here we have the area of the triangle ABC. Let's expand the determinant. So we have 0 times the c minus 0 multiplied to c over m2 minus c over m1, and then we have 1 added to c squared over m2 minus c squared over m1. Okay, so let's solve this determinant. So we have half. The first two terms is going to go to 0. So in the third term, we're going to be left with c squared multiplied to m1 minus m2 whole divided by the product m1 times m2. Okay, so we have c squared over 2, the absolute value of m1 minus m2, divided by m1 times m2. So this is going to be the area of the triangle ABC. So this is our area of the triangle ABC. However, we are not quite there yet because we now have to find out the value of m1 and m2. So what is m1 and m2? It's given in the problem that m1 and m2 are the roots of the quadratic equation. So let's solve this quadratic equation to obtain the roots m1 and m2. The m1 and m2 are the roots of the given quadratic equation. So let's use the standard quadratic formula to find out the values of x. So x is going to be equals to, so we need negative of the coefficient of x. So that's going to be square root of 3 plus 2. Plus or minus, we'll take the square root. Underneath the square root, we'll first take the square of the coefficient of x. So that's square root of 3 added to 2 whole square. Then negative 4 times the coefficient of x squared. So that's 1 multiplied to coefficient of the constant term, or you can say it is simply the constant term, square root of 3 minus 1. This is going to get divided by 2 times the coefficient of x squared. So now let's simplify this. So we have negative of square root of 3 plus 2 plus or minus. Now when we expand square root of 3 plus 2 whole squared, we're going to get a 7 plus 4 times square root of 3. Let's expand this. We're going to get distributing 4 to square root of 3 minus 1 gives us 4 times square root of 3 added to 4. So we have 4 square root of 3 and negative 4 square root of 3 cancelling out, whole divided by 2. So that's going to give us negative times square root of 3 plus 2 plus or minus square root of, so 7 added to 4, that gives us 11, whole divided by 2. So that's going to be x. So here we have obtained two values of x. So here let us suppose that m1, which is going to be one of the roots, that means we can say m1 is actually x only. We're going to consider negative square root of 3 plus 2 plus square root of 11 over 2 to be m1, and we'll consider m2 to be equals to negative square root of 3 plus 2 minus square root of 11 over 2. Okay, so we have obtained the value of m1 and m2. Now in order to find out the area of the triangle, what we need is the difference of the two roots, m1 minus m2, and we also need product of the two roots. So let's do one thing. Let's try to first find out m1 minus m2. So we have negative square root of 3 plus 2 added to square root of 11 divided by 2, minus, we need negative square root of 3 plus 2 minus square root of 11 divided by 2. So our common denominator, that's going to be 2. In the numerator, we have square root of 3 minus 2 plus square root of 11. Negative, and this negative is going to make it positive. So we're positive square root of 3 plus 2. This negative sign and this negative is going to make it positive. So we're positive square root of 11. Now, negative square root of 3 and positive square root of 3 cancels out. Negative 2, positive 2 also cancels out. That leaves us with 2 times square root of 11 over 2, which is simply equals to square root of 11. So m1 minus m2, that's equals to square root of 11. Okay, next we'll try to find out the product of m1 and m2. So we have m1 multiplied to m2. Now clearly we can see that m1 and m2 are conjugates of each other. So here what we'll get is negative square root of 3 plus 2, let's square this value, minus square root of 11 whole square divided by, well, 2 times 2, the denominator simply becomes 4. So here in the numerator, now we have 7 added to 4 times square root of 3 minus 11 divided by 4. So that's going to give us square root of 3 minus 1. So the product m1 times m2 comes out to be square root of 3 minus 1. Okay, so let's now find out the area of the triangle. So we obtained it as c squared over 2 times the absolute value of m1 minus m2 divided by m1 times m2. So we have the area of the triangle ABC. So that's going to be c squared over 2 times. Now what we need is the absolute value of m1 minus m2. So that's square root of 11 divided by the product m1 times m2. So that's square root of 3 minus 1. Okay, so what we'll do, we're going to rationalize the denominator. So we have c squared times 2. So in the numerator, we are going to multiply it with square root of 3 plus 1. And in the denominator, we have square root of 3 minus 1 multiplied to square root of 3 plus 1. That's going to give us c squared over 2 times. So square root of 11 times square root of 3, that's simply square root of 33. Added to square root of 11 times 1, so that's square root of 11. Divided by square root of 3 minus 1 times square root of 3 plus 1. So that is going to be simply square root of 3 whole squared minus 1 squared. Now we have c squared over c squared times square root of 33 plus square root of 11 whole divided by, now square root of 3 squared, that's 3. 3 minus 1, that's going to be 2. So 2 times 2, that's 4. So we have finally obtained. So we can say hence the area of the triangle ABC, so that is going to be equals to c squared over 4 multiplied to square root of 33 plus square root of 11. We have successfully verified it. So that's equals to c squared over 4 times square root of 33 plus square root of 11. And that's exactly what we have obtained. Hence proved.